Yeah, hi, welcome from our side to our talk about Ripple-Lib and open source banking in Java. So what are we going to tell you? So first we're going to introduce you to Ripple. I'm going to tell you what it is and a little bit about the technology behind it. Then we'll show you a live demo in JavaScript, how you can very easily transfer money in this network. Then we're going to talk about more Ripple, a little bit more details about the data model, and in the end we'll show you Blitzbay, which is this app we built for the hackathon. If you have any questions during the talk, just go ahead. You don't have to wait till the end. Okay, so what is Ripple? Ripple is basically a decentralized monetary system and payment network. It's been developed since 2004 by Ripple Labs and the predecessors. It's the second largest cryptocurrency behind Bitcoin, and many say that it eventually will overtake Bitcoin because it has a lot of advantages. And one very important advantage is that it's currency agnostic, so it doesn't care about the currencies which are traded in the network. This means with Ripple, you can actually make transactions from one currency to another currency. You can invent your own currencies, and everything is very fast. So in Bitcoin, you maybe need 30 minutes for a transaction. In Ripple, you need 5 seconds for a transaction to be verified. The fees are very low. I think 1/100th of a percent per transaction, just a spam protection. And this is basically Ripple from a very high view. So you know it's a monetary system. And now Martin will tell you how it actually works and how it's implemented.
So what is Ripple actually? Maybe a show of hands who has heard about Ripple before this talk?
Sure.
Not so bad. How many of you have heard of Bitcoin? Wow. Keep hands up if you actually own or use some Bitcoin? Not too bad. Cool. Okay, so Ripple is in some aspects similar to Bitcoin, especially the version that has been set up since 2012, like after Bitcoin, on this new technology. Basically what it is a decentralized database. So it's just a database of accounts and account balances, basically, known as the ledger, which is distributed across the Ripple network. And this allows, like Bitcoin now, to process operations without a central operator. So before you had to have like a bank or a payment processor like Visa or something to process transactions. And here you can actually do it on the internet without relying on one single point of failure or one single business entity. And this is similar to what Bitcoin does, right? They have a public database as well to prevent the double spend problem. So you don't want to have people spend their money at 2 locations. That's kind of more complicated than email, right? If you send an email twice accidentally, it doesn't matter much. But if you would send the money twice, that's really a big issue. So that's called the double spend problem, and Bitcoin has been solving this very elegantly, and so does Ripple, with a lot less computing overhead, I have to say. So if there's a public database, there need to be rules, of course, who can change what in this database, so other people don't have access to your money. And this is done just like Bitcoin with a public-private key cryptography system. So each account has attached a private key, and only if you sign your transaction with your private key, then you have access to the funds in the account. And what you do, you just connect to any of the Ripple nodes, basically, and you can do this with JavaScript. Actually, the native library for Ripple is JavaScript, and then you have access to this network. So what is stored in this database? The data model, the basic data model, is actually very simple. So we mostly have accounts in there, and accounts can represent anything, like it can be an individual, it can be legal persons like corporations, it can be banks, even like central banks could just be represented with an account on the Ripple system. And then between those accounts, we would have so-called trust lines. And the trust lines are what keeps the balances on the Ripple system, so how much money in your account. It will become clear in the example. So imagine we have a bank on the Ripple network, which is presented by an account, and then the bank has two customers, here Annemarie and Bernhard, and they are also represented by a Ripple account. And let's imagine they basically have a checking account with this bank with a certain balance, and this checking account would be represented by a trust line. But if you think about it, what's a checking account? You take like 100 euros, you take it to your bank, they put it in their computer system, and what that means is the bank owes you 100 euros, right? So it's really this relationship between you and the bank, and that's exactly what the Ripple database stores. So if this trust line has a balance of 2,420 euros, it means the bank owes this customer this amount of money in this currency. So that's basically all there is behind it on a simplified level. Again, if you have any questions, please ask them. Okay, so far we don't have any major banks on the Ripple network. There's a small bank in Munich who's actually attached to the network, but you can't just keep their balances on the Ripple network. They're not that open for regulatory reasons at the moment. But there are other like bank-like entities on the Ripple network which actually give you balances on the Ripple network, so where you can hold your money on the Ripple network. These are called gateways because they also function as the connection to the traditional banking system. So what you could do if you want to have some euros on the Ripple network, you could send them to SnapSwap, for example, and they would issue a euro balance to your Ripple account, which you can withdraw again by sending it to SnapSwap. Okay, so to show you how this works, let's try to get the live demo working. Great. Okay, so what do we do? Let's create just a directory. And as I said, that's basically a node module, so I'm not going to download the internet, so I just have this cache alias here. So what I only do is simply install Ripple-Lib. And that's what I have done, right? And now I can just access the Ripple network by including the Ripple-Lib. And the first thing we need to do is create a remote connection to the Ripple network. So we create a new Ripple remote. And this remote needs some parameters. Actually, it mostly needs one parameter, which is which server it has to connect to. So this is using WebSockets, and you can just connect to one of the servers that is provided to the Ripple network by this Ripple-Labs, which is a startup in San Francisco, which is maintaining this Ripple network and the code. And then you can connect to the Ripple network. And to see how this works, oops, sorry. Just let's say we're connected. And let's see, it says connected. Okay, so in the background we just have now a connection to the Ripple network. And now we can do some stuff. So, for example, we could look at what we have in our account. And what we need here is a account object. So we just ask the remote for an account. And now we need to use these Ripple addresses. And actually, I did prepare this well for a single screen setup. So bear with me for a second. So I just have some accounts. We actually have like a secret key for this account, so that's a private key for the encryption. And let's get another account, which we'll need right now.
The talk is video recorded.
Yeah, I know. There's no real money on it. So, okay, don't steal any money. No. So now we have the account object, and we can ask the account object for the lines, which are the trust lines we just talked about. And what most of the Ripple functions give you is a callback, because everything is asynchronous, right? So, and we get basically an error and a result back. And then what we can do in the result, we have the lines, and we can just loop over them, and let's say we want to print this. So let's just print the balance, which is like the most important thing, and the currency. And the last thing is the account, which is the account that actually owes you the money. So we're basically looking at one of the customers of the bank here, and now the account in this case would be, let's make the winter happy, would be who owes you this money. So let's try if this works. Okay, great. So in this case we have two trust lines with a balance of 55 euros and 9 US dollars, and both are owed by this bank's account that I created in Ripple, right? Cool. So now let's send some money with this. So what we do is we create a transaction, and in this case a payment transaction. So we want to send some money from account A to account B. This means we specify the sender account, which is A, we specify the destination account, which is B, and we specify the amount to send, which again is composed of these three parts. So we can send like €1, and then what we have to specify is like who's issuing this. Like, are we sending money owed by the Sparkasse or by whatever? This needs to be specified, because we might have, like, as an account in Ripple, you can have like checking accounts with different banks, right? And the destination account can have as well. So what we need to specify is what kind of euros we want to send them. So if he's at the Hypo-Vereinsbank, for example, we want to send him Hypo-Vereinsbank euros. That's what would happen in the real system, right? If we transfer euros to his Hypo-Vereinsbank checking account, he would get basically Hypo-Vereinsbank euros, which means the Hypo-Vereinsbank owes him some euros. And in Ripple we have to make this very explicit, so that's what we have to say here, right?
You have syntax.
Okay, so what happens if we submit this transaction now? And submit again is asynchronous, so what we would get back is again an error and a result. And yeah, just to show you what happens, let's output the error for now. So, of course, we can't just send anybody's money in this public database. So what Ripple is telling us here is we're missing the secret. So we need to provide the system with a private key, of course. So that's what I conveniently provided up here, right? So we can just tell the remote about the secret, and we say we should use the secret for the account, and now it should actually work. So maybe what I should do here is show you the accounts. So I have both accounts here opened in something called Ripple Trade. This is basically a hosted wallet software that's provided by Ripple-Lib. And this is also a JavaScript client which you can use. And it's showing the account balances. And if we just run this again, and it's still there, you will see again it was like 44. Why doesn't it stay on here? No, it does. Okay. So once again, you should see some money transfer between those accounts. And you see it just takes a couple of seconds. Okay. You can see in the result all kinds of things, and maybe one thing is the hash. So every transaction is given a cryptographic hash, and that's also the ID of the transaction, and it has the signature which is signed by your private key. So that's basically everything I wanted to show in the live demo. Already half of our talk, and now something more interesting in Ripple that's very cool is the order book, because as you saw we can have multiple currencies in there, and so it's very convenient that within Ripple you can actually do some trading. And this means inside Ripple there are order books where any account can put in orders. It's just basically limit orders where you say you would be willing to sell 100 euros for 110 US dollars, for example. So you would put that inside Ripple and say the taker gets 100 euros and he would have to pay the 110 US dollars to you. And then somebody else can come and take this offer. And actually this offer can be taken within a payment transaction. So there are more options to the payment transaction. And what you can do if you have euros on your account and you want to send something to a US dollar account, you can specify that you want to send euros and the destination should receive US dollars. And you can specify the exchange rate that you're willing to accept. And then processing the transaction, the Ripple network would look at the offer book and use a matching transaction and actually do this in an atomic transaction. So this means you don't have the risk of like a changing exchange rate because you didn't define it before. You don't have the risk of accidentally holding the wrong asset. And it's really an atomic transaction across 3 accounts then, because your account has less euros, the market maker's account to put in the offer now has more euros and less US dollars, and the receiver who you actually want to send money to has now his US dollars. So 3 accounts balances are changed in one atomic transaction. And that's something really cool that you can do if you have everything in this global payment network. And this just happens within a few seconds. So, to show you how this looks like, there's a site called Ripple-Charts, which gives you live info about this trading happening. So you have it's a little bit small, isn't it? So you have recent trades here. You don't need to see the details. Yeah, and you can see the history of what the price was. You can actually see the order book, what the current bids and asks are. It shows you the structure. So, yeah.
What is that? That's server log? Or?
Sorry?
This is what?
This is
personal log.
This is a web page that's accessing the Ripple network and showing you the last transactions of, in this case, trades between the US dollar of Bitstamp and the US dollar of SnapSwap. So these are basically 2 banks, and they both issue US dollars on the Ripple network. And because like different people trust different banks, basically have accounts with different banks, they're not compatible by default. So they're made compatible by market makers who put in trades between those currencies, basically. And so you see the prices like kind of almost at 1. Interestingly, in the last 2 months, it kind of deviated from 1 a bit. I don't know what happened, but maybe they don't trust this one bank so much anymore. Yeah, so that's what you can see in this network.
How is it established that there are not dollars or any other currency created out of thin air?
You can do that. So, I mean, that's exactly what I did, right? So, with my demo account, I just have like one account that I define to be as a bank, and then I create trust lines from other accounts. So that's what you need, right? You need other people to trust you, and you need to have them configure this on the Ripple network, and then you can just issue that. That's just what happens with real banks, right? If you go to a Sparkasse and say you have opened a checking account, they can just like put any amount of money on it, basically. And that's actually what they do when you take out a loan, right? They put just like 1,000 euros on it, and they put 1,000 euros on your loan account, and so in sum it all levels out, but you have like now 1,000 euros on your account. And I mean, there are also banks that take advantage of that, like recently in China, they opened like a fake bank with branches and offered good rates, and people brought their money in, and the next day the bank was gone. So, I mean, it's just the real world, right? You can create fake currencies, and you can basically create any like 3-digit currency, even like 100-bit. The currency is 100-bit value, 160-bit value. You can like have custom currencies in it. Yeah.
So how does it work with the trade offer? So if I make an offer, I want $110 US, do I know whether I'm going to get Martin dollars or Konstantin dollars?
Exactly. That's what you say here, right? So you have the what your taker has to pay, which is an amount, and the amount always has like 3 components, which is the currency, the value, and also the issuer, which is like really important. It's like the bank where you want to.
This is the amount, 3 parameters, yeah?
Yes, amount is always these 3 parameters. That's what we saw in the trust fund before, right? It's always these 3 things. It's the amount, the currency, and the issuer. It's the institution where you hold the money. Okay, cool. So this was kind of the data model that's changed dynamically. I'm not going into details of all the other properties here. I showed this, and Ripple also saves the transactions, right? So you post transactions, what we did with the payment transaction before, and so you have this history. All those accounts and balances and trust lines, they only change because somebody put a side transaction on the network, and then you have like different kinds, like the payment transactions we saw. Or you have like offer, create, and cancel to put stuff or remove stuff from the order book, or to add new trust lines. So you like, add a trust to a bank, for example, or set some flags in the account. So that's just to complete like your view of the Ripple data. Okay, that's it. What I'm going to tell you about Ripple today. And if you want to find out more, there's the Ripple Developer Portal, which is actually quite nice because you can play around with it. It's like an interactive API documentation with live connection to the network. I showed you Ripple Charts. Ripple Trade is the hosted wallet, where you can create an account on the Ripple network. It has by now an ID requirement, so you have to register with your passport actually. That was some regulation recently put into effect by the FinCEN, the American and the US financial regulator. Ripple is by now not the only network that's offering something like that. It is the oldest and the most established one. But there's Stellar, for example, which originally was a Ripple fork, but now they have an independent code base. And there's Hyperledger, which is doing something similar, like more specialized for certain things. And I also recommend reading if you want to understand more of this financial background and accounting stuff. Don't run away, it's interesting, really. So that's the title of a blog post there, which explains this stuff. I think we're going to put the slides online, so you can just click on. Okay, and now Konstantin is going to tell you something about Blitzpay, which is a little app we built on top of Ripple.
Yeah, Blitzpay. So maybe let's start with the idea we had, or the problem we wanted to solve. Almost every noon here at TNG we order takeout, and usually one person then pays for everyone, and then this person has to collect the money from everyone. And this is always a kind of tedious process because the amounts usually aren't that even, and you don't have the right amount of money with you or something like that. So we wanted to make this process easier. And if you think about it, actually there are more use cases to this sharing of money. So I don't know, maybe you split a cab ride, or you split gas money, or just somewhere where you have drinks and one person pays and the others also want to pay their share. So this was the problem we wanted to solve, and since we knew Ripple, we thought of Ripple to solve it. And actually Ripple has a lot of features which are very nice for this problem, because for example, one of the important ones is it's real time, so the person which collects the money sees who pays for it right away, and not on his bank statement 2 days later. Sees, okay, this person actually hasn't paid, or he didn't have any money on his account, so he has to go back. Yeah, so real time is important. The other thing is it has basically no fees for the customer, and it also has no fees for us to implement. It's free for us to use. And the last thing are those trust lines, and you can actually, if you configure the trust lines right, you can add trust lines to your friends, and then the friends don't actually have to have, for example, SnapSwap Euro on their account. They can just give you money without having them, and then you have credit at their account, and they owe you money in Ripple. And that's okay as long as they're in bounds of the trust line. And you just say, okay, overall it will even out, and if not, okay, we still have it documented in Ripple, and we can even it out sometime later. So with those trust lines, you can actually kind of create your own social context in which everyone trusts everyone, and it evens out. And no one actually has to use one of the gateways to transfer money into Ripple. Okay, so this was the idea, and since we have a lot of demos, we have another demo, and we'll show you how it actually looks like and how it works.
So let's see. Oh no, did I close the demo? I did. Okay, so no, it's just a. Do we have a third one? No, I closed it, sorry. Okay, we just use 2 ones then, it's not as spectacular, but almost as nice. So, we have 2 accounts?
Yeah. So 2 accounts, there you see basically the trust lines you've seen in the other live demo. Annemarie and Bernhard, and they're both logged in with their secret. And now maybe Annemarie, or actually Bernhard, has paid for lunch, and he wants to get paid by the others, so he creates an event called lunch maybe for 50 euros. And now there's this event code which gets generated, and all Annemarie, I think, has to do is to type in this event code and type in their share, which maybe 550, and then the money is transferred. And as you see, Bernhard sees it right away, and yeah, that's basically it. That's what BlitzPay does. It works with more accounts, obviously, and yeah, actually, we can go back to the presentation. Yeah, which frameworks, technologies did we use to build it? First of all, the front end is basically React. It's a Flux-like architecture. It's not real Flux because it was a hackathon and we were under some time pressure and couldn't afford to make it. Yeah, perfect Flux architecture. On top of React, we use Material UI, which is basically a collection of React UI frameworks based on Google's Material UI. It's there's a lot of development going on there, like releases every 3 to 5 days or something like that. Takes some time to get used to, and you definitely have to write your own CSS too, but has some very nice components. Backend is Node.js. It's basically just an Express REST service which generates and submits the submits the event codes. And that's all the backend does actually, because our main backend is the Ripple network itself. So all the handling of the transactions is done in the Ripple network, and we also use to the transactions you can attach memos, which are basically just random, not random of course, but just attribute value pairs, and this we use to relate BlitzPay events to actual Ripple transactions, and you can just add all the information you want there, and then you find it again in the Ripple network by looking up the transactions for accounts, for example. Yeah, and then last and least, we have MongoDB to store the event codes. Yeah, you can use it. It's on blitzpay.bits. You just have to type in the 32-character secret. It's only kept in memory, and yeah, that was our presentation on Ripple. I hope you will use BlitzPay, and I hope
we implement a proper login mechanism.
Yeah, we will actually, yeah. But we have to think a little bit about how to do it in a safe way, because then we have to store your secret key, and this shouldn't be too insecure. Yeah.
Is there any way to reject transactions? If Anna-Marie tries to cheat and say, okay, instead of paying €6, which she pays €5, is it possible to say no?
No. You do this kind of in a Ripple network by specifying the trust lines before. So what you really say, you trust this bank or this person or something for up to $50 or like 2,000 euros or whatever. And then the Ripple network makes sure that the balance never goes higher than that. So
individual transactions in that.
But you can't reject like individual transactions. They're just coming. But you will always own just the assets of other Ripple accounts. Yeah, that you define. Just accounts that you trust, like just your own bank.
One question, can you please repeat the question?
Oh, yeah. So the question was if you can reject individual transactions.
And this question.
Yes.
Have there been any major successful attacks on Ripple?
The question was if there have been any major successful attacks on Ripple.
Do you know?
I can't remember like really anything like targeted at the Ripple network itself. Of course, people get their private keys stolen because their laptops get compromised or something. This happens. There were some bugs in Ripple. For example, there was a bug that actually I reported, where people could move balances between banks you had. So if you had a single account with trust lines to two banks, there was like a loophole that allowed attackers to move like the $100 you had at Sparkasse to $100 you had at Vereinsbank. And now you saw before, it's not one-to-one always in the Ripple system. So if the attacker is able to do that, and like he would get the more valuable euros. So it still was within the limits that you specified in the trust lines. So it was kind of okay, but this if you disable it and it's disabled by default, it shouldn't actually move this. This is like an essential Ripple feature that you might want to enable, especially in this community sharing use case, where we say it should actually, like, that's why it's not Ripple, it should ripple through other accounts. So if I owe something to Konstantin and Christoph owes something to Konstantin, and then, so how do we do this exactly? And I also owe something to somebody else, then maybe if somebody wants to pay Christoph, it's okay if my balances change. And like one of my friends owes me less and my other friend owes me more, so the transaction can take place. So that's just an essential feature of Ripple, but you can disable, and the disabling mechanism didn't work exactly. I think that was the major attack I could think of.
Cause resolve.
Yeah, probably.
All the APIs are provided by Ripple itself. You know, to use transaction.
Yes, so you have this Ripple network, right? Which are not all nodes are created equal, basically. So every node is just an instance running this Ripple daemon. but some nodes are kind of special, they're validators, so they actually take part in validating the transaction and making sure that no invalid transaction gets onto the network. And this is kind of done by manual configuration. So there's every server that wants to act as a validator has to specify a list of other validators that it trusts. And
is it centralized or controlled by one organization or no?
I guess also if it's centralized and controlled by one organization, no, not really. So at the moment it kind of is, because I think like the majority of servers are still run by Ripple-Lib, which is the startup that created Ripple, but there are also other organizations of Ripple. You could basically just fork their code or like use their code and start your own Ripple network. But there's always like a list of servers that build like the main cluster of Ripple, and you ideally want to choose like organizations that you think would not collude against you. So if you choose organizations that like maybe are non-profit somewhere and like something from Russia and something from the US or whatever, and like a couple of dozen of them, you would be pretty sure that the majority of them won't collude into defrauding you. So if you can ensure that, then you don't have a problem. Any more questions?
And for the protocol itself that's implemented inside the Ripple network, it is not needed to know the complete log of the transactions like in the Bitcoin. Do you understand the question?
I don't
think that the biggest problem for the Bitcoin now is that the log is growing rapidly.
Mm-hmm.
So you cannot host it anymore because it's too big. Last time I installed it was something like 6 gigabytes now, definitely more. But Ripple network doesn't have the same problem.
Okay, the problem you're talking about is if the database is
logging
growing
of
too large,
complete
basically,
transactions.
and the amount of transactions is
Yes.
getting too much for the network. Okay, so one thing that's different here is in Bitcoin you actually don't store current balances, you always store only transactions, and what you spend is like unspent outputs of other transactions. Well, that's why in Bitcoin you basically need the complete history, or at least all unspent transactions. And that's quite a lot. In Ripple you actually always just need the latest ledger, and then you have all the accounts with their balances. So that's why Ripple nodes that don't want or need a full history, they can just operate with like a very limited history and with a less amount of memory. And the transaction processing is also far more efficient, so it can process a lot more transactions per second than Bitcoin because it doesn't use this expensive mining process, but some other consensus process to decide which transactions are valid on the network and adhere to the rules.
Okay. Thank you.
Thank you.
Thank you.